this looks scary, but it's not. You've done all this before. Okay, so a polynomial, okay, that's this word right here. Okay, we've already used that word in class, but it's an algebraic expression where you can write it in this form. So a to the n is the number in the front. Okay, that is called a coefficient. Okay, x is a variable. You already knew that. Each constant multiplied with an x is called, we'll go ahead and write it here, a coefficient. And then the coefficient a0 that does not have an x is not called a coefficient, it's called a constant. Here's why. If it doesn't have an x behind it, okay, like if your x is to the 0, you don't have a term, so that's your constant. So this last number here is the constant, okay? Versus all of the other ones that are buddied up with an x, those are called coefficients. Okay, then if you don't know what an integer is here, okay, that means a whole number. So what that means is that if any of your equations have fractions as exponents, nope, not a polynomial. If they have a negative exponent, nope, not a polynomial, okay? So the degree of a polynomial is the highest power of x, okay, that is the degree of the polynomial. And the coefficient in front of this term is called the leading coefficient. So the highest power is the degree, and the coefficient in front of that power has a special name. It's the leading coefficient. Okay. So you have a couple of special names for the first four types of polynomials. If you have y equals mx plus b, okay, that's called linear. And that's when you have an x to the first degree. So if I write x, technically that's an x to the 1. You just don't have to write the 1.
So it would be like, the second would be like x2?
Second one is x2. What is the special name for the family of functions that have an x squared? Quadratic. And that's just y equals ax squared plus bx plus c. Okay, so if you have an x squared, it's in the quadratic family. If you have only an x, it's in the linear family. Okay, the third one is x to the 3. That's the cubic family. Very good. Okay, and that would be ax cubed dot dot dot. You can put bx squared cx plus d if you want. Now I guess we should do it since it's your notes. So bx squared cx plus d. And remember, the very last letter that doesn't have an x with it is not a coefficient, it's a constant. Okay, then your last one, which is x to the 4th, that is called a quartic. Okay, and no one ever really uses that word. You should really know up to cubic, but the 4th one's called a quartic. Any guesses on a 5th? Quintic, like quintuplets, you know? Okay, but you don't have to write it if you don't want to.
What's number 7? Like
No, ma'am.
I actually don't know. I don't know after 5th. So that one just... Okay, so then good point here. Listen. If it's a polynomial after 5th, which is quintic, you would just say it's a polynomial of degree 6. Or a polynomial of degree 7.
I'm confused somehow.
Okay? So come down to your little chart here. You have a couple of these on your homework. Okay, first one, look at the equation. It's a polynomial. All of my exponents are whole numbers. I have numbers in the front. None of them are fractions. Okay, what is the highest degree? 7. It's a 7th degree. Now, on that term, that's the highest degree, what is the leading coefficient? 6. What is the constant term that does not have an x? Plus 10. That's the one with no x. Okay? Next row, I'm going to give you a second. Look at it carefully. What is the degree of the second polynomial? Yes, look. Even though it didn't come first, x to the 8 is the highest. That's an 8th degree. Okay, now for your coefficient, leading coefficient, if there's not a number there, it's a what?
1.
A 1. Positive 1?
Negative.
Negative 1. Because it's like a negative 1 x to the 8th, right? Okay, then your constant term is what there? Negative 4. Very good. Next one, what's my degree?
Third.
That's a third degree, or what could you call it?
Cubic.
Cubic. That's one of the ones that has a special name. What's the leading coefficient in front? Positive 1 if nothing's there. And then your constant term, you would say there's a plus 0. 0 counts as a constant too. So if you want to add that in here.
What if there's no degree?
Okay, good question. If it's just a number, is it a polynomial?
No.
Okay, it doesn't have a leading coefficient, but it does have a constant of 12. So if there are no x's, that is not a polynomial anymore. That's a constant only. Okay?
Nayeli's birthday, right?
Whose birthday?
Nayeli, the one that graduated?
Oh,
What did you think?
Got
okay.
excited too.
I love birthdays. That was going to turn my whole day around. Okay, so look at the bottom. Addition and subtraction. You can only combine like terms when you're adding and subtracting. When you're subtracting, you're going to use parentheses. This is easy, easy. You already know how to do this. So if I'm looking at number 1, I am adding these polynomials together. Then I can only add like terms. That means x cubed with other x cubes, x squareds with other x squared, constants with other constants. So who is my first pair of partners?
3x cubed, 2x cubed.
Okay, what is 3x cubed plus 2x cubed?
5x6.
Keep it a cubed.
Cubed.
Okay, because remember, when you're adding, you're just combining. You're like, okay, I got 3 over here, 2 over here, bam, now I have 5. Okay, next, guys. 7x squared minus an x. Can I put those together? No. 7x squared minus x stay separate. Those are not like terms. Okay, so I'm going to put here, not like terms.
So it has to be like.
The x's have to be the same power for them to be like terms.
5x cubed plus 2x 4.
Couldn't do that.
Okay.
Okay, then last term, and I should have circled these in different colors, so I'll try to, I don't know, fix it. I'll make it black. Okay, this one is black now. Okay, those can't go together. And then last two numbers, 9 and 10, make how many? 19. Okay, now keep in mind that when you add polynomials, okay, you should not be changing any of the exponents.
You don't solve nothing.
You're just only adding, correct? Okay, take a look at number 2. This time you're subtracting. Look at your little note right here. When you're subtracting, you need to use parentheses. The reason why is that this x, or this negative, is going to need to distribute into each of the terms being subtracted. So I'm going to rewrite the whole thing. If you want to just rewrite the second one, that's fine. But it's going to be a negative 2x cubed plus x squared minus 4x plus 1. All of that's the same.
Hey.
But then now it's a minus 2x cubed. And what happens to minus negative x? Turns to a plus. Then the minus on the 4 is a. And after you distribute that negative, you don't need the parentheses anymore. You're going to put your like terms together. So first, partners, who are you putting together?
Negative 2x cubed.
Okay. Negative 2 minus 2 more. How many?
4. Negative 4.
Good. Now keep in mind they could only cancel if 2 are negative and 2 are positive. Yep. Okay, then I have an x squared here all alone. No other squareds to go with them. Then I have a minus 4x and a plus 1x. Put a 1 in there if you want to.
So
Negative 4 plus 1, how many stay?
5.
Nope, 3x. Okay, and then last one, I have a plus 1 and a minus 4. So minus 3. Okay, somebody borrowed $4 and they paid me back 1. Make sense? Easy? Okay, turn the page. So add and subtract, we should be good with that. When you turn the page, we're going to multiply. And then tomorrow we're going to divide. Okay? May I go? Good.
Go.
Girl, bye. Okay, multiplying polynomials. You can multiply terms that have different variables. So, and actually we'll leave it like that. Okay, so you are going to multiply the coefficients. Those are the numbers in front. You are going to add the exponents. So, for example, if I was doing 3x cubed times 7x squared, I'd do 3 times 7, that's what? 21. Then I'd do x3 plus x to the 2, I'd get x to the 5.
Wait. Okay.
So you multiply the numbers in the front, you add the exponents.
Oh.
Good. Okay, look at number 4, what's it going to be?
56.
Okay, 8 times 7 is 56.
And then just square.
Nope.
I mean,
That's an x to the what? 1. Added together, it's a 3. So if you have an x with an unlisted power, that counts as an x to the 1. Okay, then last one, my x here, that's really a 1x. So 1 times 2 in the front is
6.
2, and then x to the 6. Good.
That's still stupid.
Make sense? Okay, last thing we're going to do. We don't have to do all of these if you kind of get the idea. But start off with, let's say, number 6. You're going to have to distribute. Okay, so what is 3x cubed times 5? I said that wrong. 3x squared times 5x cubed.
15.
3 times 5 is 15. X is to the
6.
add
Oh, 5.
5. Because remember, you're taking 2 from the outside, combining with the 3 x's on the inside. Okay, next one. I have 3x cubed times negative x squared.
Negative 3x and 4.
To the 4, very good. Okay, next term, we have 3x squared times minus 4x. What's 3 times minus 4?
Yeah.
And x is still squared?
Yeah, 3. Cube.
3, good. Because remember, that x counts as an x to the 1. You can write it in if you want to. Okay, then my last one, 3x squared times 2.
6x 2.
3 times 2 is 6, and then my x squared just stays the same. Nothing to combine. Make sense? Okay, take a look at number 7 right next to it.
You can't do that.
Okay, where am I going to distribute on number 7?
This is right there.
Good. Now, am I distributing in the first parentheses? No, so I'm going to leave that the same. 10x4 minus 6x cubed. Okay, I'm going to leave that exactly the same. So this guy and this guy, that just carries down. I'm not distributing there at all. But then when I do my 2x, I need to bring the minus in with it as well. So I'm going to have negative 2x times 5x cubed. What will I get?
Negative 10x.
To the 4. Okay, then I'm going to bring it into the next one. Negative 2 times negative 1 is a
So 2x.
plus 2x3. Good. Negative 2 times negative 4 here, that's a
8x.
8x squared. And then last one, negative 2x times 2 is negative 4x. After you distribute, you're going to look for your like terms.
Combine that.
But you cannot combine until you times that x in, because it changes whose partners are whose. Okay, so where are my x to the 4th terms?
10x.
They're going to do what though? Positive and a negative, those guys are gone. Then what is negative 6 plus 2 to combine these two guys?
Yeah,
Negative 4x cubed stays the same for the power. Then I have a plus 8x squared and a minus 4x. Okay? Alright, last one we're going to do from that section. Let's do number 9. What type of distribution are 8 and 9? Double distribution. Here's how that works. You already saw this in Algebra 1 and Algebra 2. You're going to take your first term, you're going to times it in. Then you're going to take the second term, times that one in. I'm doing 9 because it's harder than 8. Okay, but you'll do 2x times x squared. What will I get there? 2x to the 3. Then I do 2x times 3x. I get 6x squared. Okay, then last term for my 2x, 2x times minus 5 is minus 10x. Then, after I've distributed that first term, I move to my second term and I'll distribute that guy. Okay, what am I distributing into the last, the minus 3, right? So minus 3 times x squared gives me minus 3x squared. Minus 3 times 3x gives me minus 9x. And notice I don't have a squared because I only had the one x. And then 3 times 5, what do we get there? Plus or minus?
Plus.
Okay, good. They're both minus, so they give me a plus. Then I look through my terms to see what can combine. Okay, 2x cubed is the only of its kind. 6x squared minus 3x squared, how many stay?
9. No, yeah.
Because it was a minus. And then I have a negative 10x minus 9 more x's.
No, X, just X. Oh, crap.
Why is it negative 19? Because I have negative 10 minus 9 more. Okay, then last term plus 15. Okay? Well, that does not work forever.
Technically.
Okay, last thing, you have two special products. The first one is going to be your squared term rule. A plus B squared is a squared plus 2ab plus b squared. Okay, this one's not hard, it's just a shortcut. So here are your two options. Let's say you want to do number 10, okay? If I have x plus 4 squared, I'm going to show you the long way, then I'll show you the short way, okay? So I could write this as x plus 4 twice. And then I would just double distribute. What's x times x? What's x times 4?
4X.
Okay, then I go to my other distribution. What's 4 times x?
4X.
And then 4 times 4? 16. Then I take these two guys,
Oh, strap.
combine those two together. What's 4x and 4x again? 8x. Okay, here's the shortcut though. Okay, if you want to skip, it's always the same pattern. What you can do is, your A is your first letter, you're going to square it. So if it was an x, I'm going to put in x squared. My last term is going to be b squared. So I have a 4, 4 squared is 16. My middle term, these guys always match. So I put A and B together and then I just count it twice. So 4 and x is 4x, double it is 8x. Okay? So we're going to do 11 and 12 by the shortcut. Do blank, blank, blank. The first blank is the first term squared. My first term is an x. When I square it, I get x squared. My last term is a 6. What is 6 squared? 36. Now, even though the 6 was negative, when I square it, what do I still get? Positive. Okay, then my middle term, I times them together and double it. So, x times negative 6 is negative 6x, but I have to double it, and that'd be your answer.
I like the other way.
Okay, if you want to times it out, totally fine. Okay, look at number 12. Blank, blank, blank. I'm doing shortcut again. You can times it out if you want to. In the first spot, I'm going to do 2x squared. What is 2 if I square it? 4. What is x squared if I square it?
4.
X to the 4th. Or if you want to think about it like this, you're doing 2x squared times 2x squared again, right? So that's where the 4 comes from. Then I add the little 2's together. That's where the exponent 4 comes from. Okay, then I got to square this guy. What's 5 if I square it?
10x squared.
25.
25, yeah.
Then in the middle, I'm going to put these guys together. 2x squared times negative 5. That's negative 10x squared, but then I have to double it.
So
20x squared.
Okay, I got that.
Okay? Now, can you times it out every time? Sure. Okay, but it's a shortcut.
Yeah, can we try again with the long way?
Yeah.
Yeah, because I kind of
I'll help you with it after we finish. We have just 3 left. Okay, the last one. These are difference of squares. Let's look for the pattern. Okay, what's x times x? We're working out the long way first. X squared. Okay, what's x times minus 4?
Minus 4.
That is 4x.
Okay, plus 4 times x is
Plus 4x.
4x.
plus 4x, and then 4 times negative 4 is 16. Good. Okay, then look in the middle. What's going to happen?
That's going to combine.
Okay, these guys cancel. Here's why.
Oh, yeah.
One of my parentheses had a plus 4. The other parentheses had a minus 4. Instead of me doubling those terms in the middle because they're the same sign, I'm going to eliminate those terms because they're opposite signs. So it'd just be x squared minus 16. Okay, now, you can only use this rule if your parentheses are conjugates. Do you remember that word from Algebra 2? Okay, conjugate just means that the sign in the middle is reversed. So look at number 14. We're going to use the shortcut, blank, blank. Okay, first one, I'm going to times these guys together. What's 3x times 3x?
9x squared.
Okay, then I'm going to times these two together. What's 5 times negative 5? Negative 25. Now, where did the other terms go? Well, one's a plus 15x. One's a minus 15x. Those would have canceled out anyway, so you can just skip them. Okay, number 15, last one. Okay, look at your terms. They're almost exactly the same, except one has a plus, one has a minus. So I'm going to do my shortcut, blank, blank. What's 5 times 5 for my first term?
25.
And what's x squared times negative x squared?
5x squared.
Negative x to the fourth. Because remember, we're doing the shortcut. The middle two terms are going to cross out.
I know that I'm saying so 5 times x squared is that.
Okay, so hold on. I'm going to do this one the long way because some of y'all seem confused. So what's 5 times 5?
5.
What's 5 times negative x squared?
5x
Okay, then I come to this x squared times 5. What do I get?
5x squared.
Plus 5x squared. Then negative x squared times x squared is negative x to the fourth. But then what happens there? Those guys cross out. So the shortcut is really just eliminating that one step, that you know your middle two terms are going to cross out, so why write them? If you want to write them though, totally don't care, totally fine.
Because the x wasn't in front first.
Yeah, yeah, and you can use that shortcut whether x is in the front or not. Okay? Alright, so you have about 20 minutes to do your homework. You should have picked it up on the way in. You're adding, subtracting, multiplying, and dividing. Turn for me, please, to number 18 on your homework.
We're not doing it.
No, we're going to do it right now.
Oh, wow.
Okay, which shortcut could I use on number 18?
Yeah. Wow.
Okay, this is a perfect square, that is a perfect square. So if you decide I don't like the shortcut, I'm going to do it the long way, you have to do it the long way twice. Okay, but I'm going to use the shortcut. So, here's my first 3. Here's my second 3. Ready? First one, what is 2x if I square it and times it by 2x again? 4x squared. Doing the shortcut. Then I'm going to skip the middle, go to the last one. What's 4 if I square it? 16. Then in the middle, I'm going to combine and double. So what's 2x times 4? 8x. Double it in the middle. 16x. Okay, now for my purple, I'm going to expand this second one via the shortcut. So my first blank is going to be the first term squared. X squared. My last term is going to be the second term squared. What's 3 squared? Does it matter the 3 was negative? No, when you square it, the negative crosses out anyway. But then put them together, that's a minus 3x, but then I have to double it.
So you did 2x squared, then 4 squared, then 2x.
Then put them together and double.
2x plus 4 squared?
So 2x times 4 is 8x, and then I double it to put it in the middle. And then combine like terms. What do I have total? X squared and x squared is 5x squared. 16x minus 6x's is 10x. And then 16 plus 9 is, yep. Okay, and you can use that shortcut any time that you have a term that's squared. So let's also do number, which one?
Number 5.
You want to do 20?
Yeah.
Okay, take a look at number 20. My first term, I notice that this one's a plus, this one's a minus. Those are conjugates. I have a shortcut for that. Remember, conjugates tell me I get to skip the middle two terms. So what's 2x times 2x? And then I get to skip the next two terms because I already know that they're going to cross out. Then I do 5 times minus 5. What's that?
Negative 25.
Negative 25. Okay, minus. Then I'm going to do blank, blank, blank. I'm going to use my expansion here.
So 2x squared.
Okay, what's 2x times 2x?
4x.
4x squared. Then I'm going to skip to my last term. It was a 5. 5 squared is 25. And then in the middle, I put them together and double. 2x times 5 is 10x doubled is good. Okay, now I'm going to get this wrong in a second if I don't fix something.
Cancel out the 4x.
Okay, yes, but before that,
The 25.
when you subtract, what do you need around the second parentheses? See this minus here? Now, are my 4x's still going to cross out? Yeah, because that's a minus 4x squared. But on my 25, when I put that negative in there, what is it now really? Okay, so I have 4x squared minus 25, minus 4x squared, minus 20x, and now that 25 is a minus 25. They don't cross out anymore for those guys. Now, the 4x squared still do. Gone, gone. Negative 25 minus 25 more? Negative 50. Very good. So I'd have negative 20x minus 50, and that'd be your answer. Make sense?
No, but go on.
Do you want to do another one?
Yes, yes.
Okay, pick one. 16?
Yeah.
Okay. Alright, I'm coming up to 16. First thing I want you to do is look and see if you see any shortcuts.
No.
No shortcuts. So we're going to just times it out. 3x times 2x.
6x.
And then if they both had an x, now it's an x squared. Okay, then I do 3x times 4.
12x.
Okay, then I'm going to move to my second term, which was a plus 5. 5 times 2x is 10x, and 5 times plus 4 is 20. Okay, then as soon as you see that minus, I want you to do this. Because when I multiply those guys out, they're getting minused together. So, what is x times 4x? What is x times minus 5? Minus 5x, right? Okay, then I have a negative 6 here. Negative 6 times 4x.
24, yeah.
And then my last little guy, negative 6 times negative 5 is a plus 30. Okay, but remember that negative on the outside is going to reverse all those last guys' signs. So here's what I'm going to do to be lazy. Okay, everybody watch while I do it so you don't get confused. To get rid of this negative, I'm going to change it to a plus, and I'm going to change everybody's sign inside. So that's a negative 4x squared, plus 5x, plus 24, and a minus on the 30. So if you want to drop that negative from the outside, just kind of distribute it in so you don't have to rewrite everything. Okay, now, who can go together? Minus 4x squared, how many stay? 6 minus 4 is 2x squared. Next term, I have a 12 and a 10. How many is that? 22x. Then I have a 5 and a 24. That's 29x. Put those guys together, I have a 51x. Then I have a plus 20 here and a minus 30 here.
Yeah. I hate you.
Okay? Then all those top guys, it looks like, are shortcuts. So like if you were doing 14, what would you get?
Crap. Oh no.
What's the first one? 7x if I square it.
449x.
Oh,
7x times 7x is 49x squared. What's 3 if I square it for the last box? Plus 9. Then in the middle, I put them together, then I double.
Also 21 plus 21.
Negative 21x, double it.
42, negative 50.
I say negative.
Good.
No, I didn't put it, yeah.
Got it?
Okay,
Yeah.
got it.
I think. I get it.
Okay, let's go on.
Okay, and then remember that if you're one of those people that needed more time on your test, it's tomorrow after school. Come right after school because I have to leave at 5 for open house, yeah.
Tomorrow? Tomorrow, what do you do? Do you think it would be better if it was Wednesday because I don't have a 6 period? I could come here.
No, I have early release Wednesday. I have meetings all afternoon. Like, we don't have just time. We have meetings that we have to go to. Otherwise,